Good afternoon, I did some raccoon math. Now, I don't know if you guys have seen this, but I got tagged about 1,000,000 times in a video of a raccoon breaking into a Virginia liquor store and getting so drunk that he passed out in the bathroom. I've been summoned, and this is my magnum opus. So let's calculate how many shots this guy took. Before I start, I'm going to preface this by saying, do not give any animals of any kind any alcohol of any kind, ever. But this guy decided he needed a drink and helped himself, so who am I to stop him? Now, because this one isn't a hypothetical and this one is a real life scenario, I'm going to dive deep. We're going to do this correct, so stay with me. I don't know if you've ever tried to find a reliable source on how large a raccoon liver is, but it's pretty difficult. However, I did it. I found an undergraduate research thesis from Ohio State University comparing the anatomy of the digestive system of rural and urban raccoons in central Ohio. Thank you, Christopher Roscoe. So to do this math, we need to remember that male raccoons are about 10 to 30% larger than females, and this raccoon is obviously able to hold its weight in liquor. So we're going to use the largest male in this study, which has a body mass of about 6,400 grams or 14.1 pounds. We also need to keep in mind that it has a water content of about 60%, which is no special deviation from typical mammalian body water range. We're also going to need to know what he drank and what the alcohol by volume of that drink was. Now, I found a couple news sources that stated he drank rum, moonshine, peanut butter whiskey, vodka, and eggnog. How festive. Now, because we don't know exactly how much of each of these he drank, we're going to assume 40% ABV because that is typical across the board, along with typical across the majority of these liquors. And lastly, keep in mind that a standard shot in the United States is about 1.5 ounces, which with a liquor of 40% alcohol by volume would have about 14 grams of ethanol. Again, we're going to use our Widmark equation. For comparison's sake, an average 180-pound person, it would take about 4 shots for them to blow a 0.08 and be too drunk to drive. We're going to scale all this down for a 14-pound raccoon, and it would take about a third of a shot for them to blow a 0.08 blood alcohol content and be too drunk to drive. But because this is real life and in real time, we're going to assume that this raccoon wasn't drinking all of this at once and it was roaming around drinking here and there. And I'm going to assume that it took about 2 hours to do all of this. And so we're going to add in our elimination of alcohol due to the liver's function. And because of that, it is going to bring our shot count up to about half a shot to blow a 0.08 and be too drunk to drive for a raccoon. But do you dumb bitch, you're forgetting that the raccoon found at this size has about double the size of a liver in proportion to a human, which means their liver size is about 4% of their body mass compared to our 2% of our body mass. So double the liver size is about double the elimination rate of alcohol, which is going to bring our shot count up to about 2/3 of a shot for a raccoon of this size to blow a 0.08 blood alcohol content. But we're not done. This guy wasn't driving. He blacked out, which means he blew above a 0.08% blood alcohol content. And I don't know if you're aware of the alcohol percentages and how they affect the body as you increase alcohol. It gets pretty bad pretty fast. However, to get blackout drunk, you need to blow about a 0.15% blood alcohol content, meaning that this raccoon zambonied approximately 1 shot of alcohol off the ground of this liquor store. And considering our previous elimination rate, it probably took him about 3 hours to sober up completely from this 0.15% blood alcohol content. So he spent the night in the drunk tank. It happens. He's fine. He got released. We're good. Thank you. You're welcome.